Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of modeling the Pythagorean Theorem. This is standard 8.6c in the great state of Texas, and we are using item number 35 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have these three square regions joined at their vertices to create this figure, and if you can see, it's kind of hidden in here, but it's a right triangle, and it's got these squares just kind of hanging off each side. But let's go ahead and label these right here. So the side that's directly across from the right angle is always called the hypotenuse. That's a special name for that particular leg. These two other parts of the triangle are just called legs. So there's the hypotenuse right across from the right angle, and then the two other parts are just called legs. And we've got these squares sticking on them. And when we're thinking about a right triangle, we probably think of this Pythagorean theorem, right? So most of us remember a squared plus b squared equals c squared. But what exactly does that mean? Well, we've got a nice visual picture here, so let's go ahead and break this down. So the a, b, and c, so these two are going to be the legs. And then that is going to be our hypotenuse. So what this means is that if you square the two legs, add them together, you'll get the square of the hypotenuse for any right triangle. Doesn't matter the size. If it's a right triangle and if it has obviously this 90-degree angle, you can do that. That's kind of a cool thing that we figured out a long time ago. Now, what does this mean for us here? Well, let's go ahead and label this. Let's just call that A. Let's call that B. Doesn't really matter which one's A, which one's B. We just need to know that our C is going to be our hypotenuse. Now, let's just take a look at this A right here. So what happens if we do A squared, right? So A squared that's just A times A. So this is just a side. So if I take that side and multiply it by another A, you see that right there? These are two A's. Really, that's what that's saying. I'm just going to take A times A. Well, that's the area of a square. If you take two side lengths that are exactly the same, right? Area of a square equals the side lengths squared. Well, you're going to get this area of a square. And so really, that's what that A squared means, is you're going to take that side length, multiply by itself, that you're going to get the area of a square. And then I've got this B right here. Well, if I do B squared, here's another B, exact same side length because it's a square, so all the four sides are the same. Well, B squared is also going to be the same thing. That equals B times B. And that's going to be the area of a different square. This is the square of B. And so we can just kind of do that. And so putting all that together, it says if you take this A squared and you add it to the B squared, then here's my C squared. This is my hypotenuse. That no matter the size of the triangle, if you form little squares off the edges of these triangles, the two legs are always going to equal the area of that hypotenuse, which is interesting when you think about the different sizes. So let's see what this says here. The number of tiles needed to cover region X, that's my A, is the same as both B and C. Nope, that's not going to work. The number of tiles needed to cover region Y, I label that my B, is both A and C. No, that's not going to work either. Let's check this. The number of tiles needed to cover region Z, C, equals the same as number A and B. Yeah, because that's C squared equals A squared plus B squared. So that is my answer, C.